Good morning, my dear students. Today I am going to start new chapter, laws of motion. This chapter is also contains of 10 marks. 10 marks. For your half yearly, it contains 20 marks. In this, you have to study first of all motion, momentum. The product of, let a body of mass m moving with velocity v or u, then momentum p is equal to m into v. Therefore, momentum is the product of mass and its velocity, Therefore, momentum P is equal to m into v. This momentum depends upon two parameters: number one, mass; number two, velocity of the object. SI unit of momentum. Momentum is kg meter per second. Easiest unit of momentum, gram centimeter per second. Dimension formula of momentum P is equal to mlt minus 1. Momentum is a vector quantity because the direction of velocity is the direction of momentum. This was the idea. All of you studied in the 9th class also. The momentum is the product of mass and its velocity. P is equal to m into v, or total quantity of motion contained in a body is also known as momentum. It is measured as the product of mass and its velocity. Momentum is a vector quantity. Dimension formula of momentum is mlt minus 1. CGS unit kg meter per second, CGS unit gram centimeter per second, and SI unit of momentum is kg meter per second. And remaining all the portions, momentum depend upon the two factors: number one, mass; number two, velocity. Is it clear? Now in this we have to study the law of conservation of momentum. It is clear that law of conservation, second point, law of conservation of momentum. In the absence of external force, total momentum of the system is always remains constant. It can be proved on the basis of second law. First one, on the basis of second law, we know that force is equal to rate of change of momentum. All of you know that one formula. According to statement, if F is equal to 0, then dp by dt is equal to 0. Differential of any constant quantity is also equal to 0. Therefore, momentum P is equal to constant. Is it clear? In the absence of external force, our statement is, in the absence of external force, F is equal to 0. Therefore, dv by dt is equal to 0. Put the value of f is equal to 0. Then we also know that differential coefficient of any constant quantity is also equal to 0. d by dt cancel out. Therefore, t is equal to constant. Is it clear? Now, if the system is made of system is made of n particles. If the system is made of n particles, if the system is made of n particles, then total momentum P is equal to P1 plus P2 plus so on up to Pn, where P1 is the individual momenta of the individual particle, P2 individual momenta of individual particle number 2, for particle number 3 P3, particle number 4 P4, particle number 5 P5, and particle number n Pn. Then again we can say that from second law F is equal to dp by dt, rate of change of momentum in the absence of external force, d by dt of p1 plus p2 plus p3 plus so on up to pn is equal to 0, is equal to d by dt of a constant quantity. Therefore, p1 plus p2 plus p3 plus so on up to pn is equal to constant. Because P is equal to P1 plus P2 plus P3 plus P4 plus P5 up to so on up to Pn. The d by dt, if no external force is applied, therefore d by dt of P1 plus P2 plus P3 plus so on up to Pn is equal to 0, is equal to d by dt of a constant. Differential of any constant is equal to 0. Therefore, P1 plus P2 plus P3 plus so on up to Pn is equal to constant, which is the law of conservation of momentum or linear momentum. It can be also proved on the basis of third law of motion. It is also based on Newton's third law of motion. All of you know that Newton's third law of motion, to every action there is equal and opposite reaction. If a body A exerts a force on the body B, and body B also exerts a force on body A, equal in magnitude, opposite in direction. That's why action and reaction do not balance to each other. And that for this one we can write the statement. In the absence of external force, total initial momentum is equal to total final momentum. In the absence of external force, total initial momentum is equal to total initial momentum is equal to total final momentum. It is on the basis of third law of motion. Now we can prove by using the third law of motion. If a body A exerts a force on the body B, body B also exerts a force on body A. equal in magnitude, opposite in direction. Let two body of mass m1 and m2, two body of mass m1 moving with initial velocity u1, body b of mass m2 moving with initial velocity u2. They will be collide if u1 greater than u2. They will be collide with each other. Body A exert a force on the body B. Body B also exert a force on body A. Equal in magnitude, opposite in direction. After collision, they separate. Body A separate. Body B moves with velocity v1 and v2 respectively. Therefore, we can say the total change in momentum or total rate of change, this collision will be take place for a small duration of time, delta t or t, we can say like that. Therefore, rate of change of momentum of A, rate of change of momentum of A is equal to how much? m1 v1 minus m1 u1 by t. Change in momentum, m1 v1 minus m1. The rate of change of momentum, it means divided by t. Second, similarly, rate of change of momentum of body B is equal to m2 v2 minus m2 u2 by t. Change in momentum, m2 v2 final momentum minus initial momentum. And then if we make the rate of change of momentum, then we divided by t. From third law, we know that. From third law, from second law, force is equal to rate of change of momentum. Force is equal to rate of change of momentum. Force is equal to rate of change of momentum. Therefore, FBA is equal to force applied by B due to A, force experienced by B due to A. Therefore, m1 v1 minus m1 u1 by T. Equation number 1. Similarly, force applied by A due to B similarly FAB is equal to m2v2 minus m1 u1 by force exerted by A on from third law, FBA is equal to minus FAB. Putting this one value, we get the result. FBA is equal to m1 v1 minus m1 u1 by t is equal to minus m2 v2 minus m2 u2 by t cancel out. Therefore, m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. M2 U2. Now transport this one term to the left hand side. We get M1 V1 plus M2 V2 is equal to M1 U1 transport this one term. Minus sign becomes plus U1 plus M2 U2. This one term is the initial momentum, total initial momentum of body A and B. Given the total initial momentum of body A and total final momentum of body A and B. Therefore, total final momentum is equal to total initial momentum. Total initial momentum. This one, total initial momentum is equal to total final momentum, and that is known as law of conservation of momentum. Law of conservation of momentum. All of you also know that the recoil of gun, that is all of you study in the 9th class, recoil of gun. When a bullet is fired from the gun moves in the backward direction. Gun moves in the backward direction, and that is recoil, velocity of the gun, which can be also proved on the basis of law of conservation of linear momentum, and action and reaction of course are equal and opposite. Recoil of gun. First of all, we assume that let capital M, mass of gun, capital V, velocity of gun, small m, mass of bullet, small velocity, small v, velocity of bullet. Therefore, initially, bullet and gun both are at the state of rest. Therefore, total initial momentum of gun plus bullet is equal to 0. Why we say here 0? Because gun is also rest, and bullet is also at rest. So initial velocity u is equal to 0. Now total final momentum of gun plus bullet. Total final momentum of gun plus bullet, capital MB plus small mb. Then, according to law of conservation of linear momentum or law of conservation of momentum, total initial momentum is equal to total final momentum. Therefore, we can write that from law of conservation of linear momentum, total initial momentum is equal to 0, and total final momentum is equal to capital MB plus small m. Transport the term. Therefore, it becomes minus small m. Therefore, capital V is equal to minus small mv by this negative sign indicates that when a bullet is fired from the gun recoils in backward direction or gun moves in the backward direction. direction. Negative sign indicate that gun and bullet moves in opposite direction. Moves in opposite direction. Or gun recoil. Is it clear? Now, equilibrium of a particle or a concurrent force. The force acting at a point on a particle are called concurrent force. If their vector sum of these forces is equal to 0. Now second point of this one, your syllabus, concurrent forces. Concurrent forces. All of you note down the force acting at a point. The force acting at a point on a particle are called concurrent force if their vector sum of these forces is equal to 0. Have you noted? The force acting at a point on a particle are called concurrent force if their vector sum of these forces is equal to 0. Note down by yourself. Now concurrent forces. Two forces. Suppose have acting at a point O, and number 3 force F3. These three forces are called concurrent forces because these forces, resultant of these two forces becomes 0. Now, how can the resultant is equal to 0? Again we draw the diagram. Suppose force acting at a particle. At point force F. Now complete a parallelogram. Complete a parallelogram. Now give the name A, B, C, so that OD is represented by force F3. OA represented by force F1. OB represent the resultant force. This is when according to parallelogram law of vector addition, when two vectors are represented by the two sides of a parallelogram in magnitude and direction, then the resultant is represented by the diagonal of parallelogram in magnitude as well as direction. Therefore, in a triangle, different side equal and opposite. Different side equal and opposite, and this one is equal to minus F3. All of you know that. Negative vector in triangle OAB. apply triangle law of vector addition. Therefore, OA plus AB is equal to OB. OA F1 vector, F2 vector is equal to, this one side is minus F3 negative vector. Therefore, now transpose this one term to left hand side. F1 plus F2 plus F3 is equal to, and then if the vector sum of all forces meeting at a point is equal to 0, then concurrent forces are said to be in equilibrium. Is it clear? It can be also, this is the one method. Okay? We can also say along x-axis and y-axis. We know that the resolution of vector. Suppose same diagram. Yeah, this one the diagram. Number of forces F1, F2, F3 are acting at point O. Is it clear? F1 makes an angle alpha. F2 makes an angle beta. Then component of force along x-axis. F2 is equal to F2 cos beta. F2 cos, here this one is the F2 sin. Is it clear? The same way, resolve F1 into two components along x-axis. F1 cos alpha, resolution में माइनस साइन नहीं लगता है, यहाँ लिखेंगे F1 cos alpha and this one F1 sin alpha. Is it clear? This one is the separate, this one is also the separate. First of all, F1, F2 are the two forces. F3, F1, F2, F3 are the three forces acting at point. And these forces are said to be concurrent forces. If the resultant of all forces meeting at a point is equal to 0, then the vector sum of all forces meeting at a point is equal to 0 is known as equilibrium of concurrent. Now, we see in this diagram which one force along x-axis. How many force? This was the x-axis. Along x-axis, resultant of force is equal to 0. We know that. Therefore, we can write as along x-axis. Therefore, F2 cos beta plus minus. This is along negative direction of x. Now O act as an origin. Origin to left, negative. Origin to right, positive. Therefore, we write here F1 cos alpha is equal to 0. Therefore, F1 cos alpha is equal to F2 cos along x-axis. Resultant of all force meeting at a point is equal to 0. Then the concurrent force are said to be in equilibrium. Similarly, along y-axis, simple way. All of you will get it at the various sides. Now you see in this figure, which one force along y-axis? This one the y dash axis. Y dash axis. Along y dash axis, which one force? F1 sin alpha. Here F2 sin beta plus below the origin taken as negative. Is it or not? Yeah. Along y-axis, F1 sin alpha plus F2 sin beta minus F3 is equal to 0. So the equilibrium, so that the concurrent forces are in equilibrium. Therefore, transpose the term. Therefore, F3 is equal to F1 sin alpha plus F2 sin, that is based on the component, and this one based on triangle law of vector addition or parallelogram law of vector addition. If the two vectors are represented by the two sides of the parallelogram, the resultant passing through the triangle. Therefore, in triangle OAB, OA plus AB is equal to OB. Now we write F1 plus F2 minus F1 plus F2 plus F3 is equal to 0. And if all the vectors are acting along head-to-tail combination or taking in the same order, then the resultant is also equal to 0. Is also equal to 0. Therefore, we can also write that force vector, velocity vector, vector A, vector B in this way. A, force F1, force F2, represented by the side A, B and B, O, F3. The resultant force is also equal to 0 because they are taken in the same order. Therefore, force F1 plus force F2 plus force F3 is equal to 0. Is it clear? Now the various forces which are acting. Now one is the lift problem, another one is the connected motion. Now we discuss according to that one.